Similar triangles. In this lesson, we will use angle-angle similarity postulate to prove triangles are similar, and then we will apply similarity. In our first example, we see a diagram of two triangles and some angle markings. We see nothing about side lengths. We are asked to determine, are these triangles similar, and if so, to write a similarity statement. So the angle-angle similarity postulate comes to mind, and that says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So angle A and angle Y, because of these angle markings, they are given as congruent. Angle B is congruent to angle Z, also given in the diagram. So we can say, in fact, that these triangles are congruent, and we can write a similarity statement. We can call the first triangle by our choice, the order of the three letters of our choice. So I'm going to say triangle ACB is similar to triangle YXZ by the angle-angle similarity postulate. Notice I said the triangles are similar. They're not necessarily congruent, but they're similar, and the order of the letters matters. Angle A and angle Y occupied the same position in the similarity statement. Angle C and angle X, the unmarked angles, occupy the middle position, and angle B and Z, which are congruent in the diagram, occupy the last position in the similarity statement. Let's look at another example. The next one will not have a diagram. Triangle EFG is similar to triangle JKL. Now, neither triangle is shown, but we can write a similarity statement like this. The measure of angle E is 32 degrees. The measure of angle K is 50 degrees. What is the measure of angle L? Now, this is how I would solve this problem. I would rewrite the similarity statement, but in place of E, put the 32 degrees. And therefore, angle J also equals 32 degrees. Then in place of angle K, I would write 50 degrees. And the corresponding angle in the other triangle will also measure 50 degrees. I'm asked to find the measure of angle L, and I'm noticing in triangle JKL, I can apply the triangle sum theorem, that the sum of the three angles of any triangle equal 180 degrees. So with the calculator, I will subtract 180 minus 32 minus 50, and I will get 98. Therefore, the measure of angle L is 98 degrees. Here's our next example. We are given that these two triangles are similar. Now, they are clearly not congruent. One is definitely bigger than the other. But we know the triangle GHI, notice the order of the letters, G, that right angle comes first, HI, is similar to triangle ZYX. We're asked to find the measure of angle X and to find the distance between G and H. So let's start with what is given, that these two triangles are similar. Now the measure of angle H is given as 37 degrees. Therefore, in the other triangle, the measure of angle Y will be 37 degrees because corresponding angles of similar triangles are congruent. Now I know that the measure of angle X will be 53 degrees by the triangle sum theorem, that 90 plus 37 plus 53 is equal to 180. And so I've solved part of the problem. It now asks me to find GH. To do that, I want to consider the scale factor. The scale factor is what is the multiplicative factor that I multiply each length by in the small triangle to get to the corresponding length in the larger triangle. The scale factor from triangle ZYX to GHI is 3, because those hypotenuses, 5 times 3 is 15. Therefore, to find the length of GH, it's going to be 4 times 3. The length of GH is 12 units. And there's one last example. Are these triangles similar? And if so, write a similarity statement. Put this video on pause. What do you think about this question? Come back when you're ready. By the angle-angle similarity postulate, I have to apply that one because I know nothing about the side lengths here. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Well, I'm given that angles A and F are congruent. I know by the triangle sum theorem that the measure of angle C is 54 degrees, because 21 plus 105 plus 54 is 180. And because the measure of angle C is 54 degrees, now by the angle-angle similarity postulate, I can state with confidence that triangle ABC is similar to triangle FDE.